now, continuing through to lunchtime. So hopefully you're in the room you're expected to be in. And if you wanted to be in the training session, that's next door on the AMS is in room D. This is the main track where we've got 3 speakers. I'm going to talk a little bit about some of the challenges we've seen in the past. And Divyang Agrawal from Thames Torrent is going to look at RISC-V, and then Sunil Mohan from Intel is going to look at SOC design verification. Okay, so I will go first. And as I said, we've been running this event in the UK for a number of years, for 12 years actually. So, and over those years, like you've seen this morning, a lot of people have given us their challenges. And what I'm trying to do is summarize those here, both in terms of numbers and also in terms of the trends. So what you can see here is that complexity actually was always the top for a very, very long time. People would see the complexity of the designs as their biggest verification challenge. And it got nearly 50% of the votes. With each speaker collected 3 main challenges. And but it has been stabilized over the past year, a few years, we've seen that stabilize and not increase. I think people now are used to that increase in complexity and don't see it as a rising challenge so much. An integration of languages and tools used to be very complex for people. I think at the time there was OVM, there was different solutions from Cadence, Synopsys, Mentor, now Siemens. There was SpecMan as well. But I think what happened was when everybody used to move to UVM, and UVM is now a very dominant language, of course, System Verilog UVM, dominant language and methodology, that integration challenge started to diminish for people. So that's not really been on the rise for a while. The 2 that have been mostly on the rise, safety verification has been going on that for a very long time. And you heard this morning from ARM on that issue as well. And security started to become an issue later than safety, but is also very much on the rise. And you saw that also again from ARM. I think it's very interesting the fact that sometimes the safety verification and security verification seem to clash with each other as well. And that's very much on the rise now. And also what I think it reflects is the fact that a lot more of our chips now go into safety markets, especially in automotive, and a lot more of our chips have to be secure. And a lot of this comes from Wilson research, and I think always give due reference to Harry Foster. I think he does a fantastic job. He's spoken at a number of these conferences in the UK, and he does a great job with this Wilson research. It's a very invaluable record. So, if you look at those, the number of multi-core designs, or the number of cores on designs seems to be stabilizing, which is why he's saying that complexity is not going up as much as it used to. 70% of projects use UVM, which is why this language and integration issue is no longer. But now 44% of ASIC designs are safety critical, and that's rising, and now 58% have security features as well, and that's why that verification challenge is on the rise. And ARM spoke to that, and Ericsson spoke to that to a certain extent as well. What we didn't see, and starting to see now over the past just 2 or 3 years, is the use of AI and ML. So I think resources there you can see is number 12. There's always been difficult, and I think some of the speakers mentioned that this morning. We can't get enough verification resources, and this is why we get try to get as many students as we can to these events to say, come into our industry because we need you. But a lot of people are looking to AI and ML as solutions for that. So I'll just spend a little bit of time talking about what we're doing in that. And we've been looking at this as well to try and make our verification a lot more efficient and within TestSolve. So starting from the requirements and specification, okay, and we look at maybe feature extraction, coverage planning, and test bench generation, and then move into TVCs, UVCs as well, and the actual tests and constraints, okay, and then simulation, debug, and coverage closure. So we've been looking at across this whole range about how we can apply more and more AI, ML, and automation into this. I think people often just jump to AI, ML as a solution when automation is actually an easier solution in a lot of cases. So just by automating some of these flows, we've got improvements. So we have been using LLM, using ChatGPT for both feature coverage and coverage planning. We've done that in quite a few designs now. We reckon we get about 90%, 10% of the effort that it used to be. And we've measured the quality, and the quality is just as good. So just on feature extraction and coverage planning, we're now able to generate the feature list and the coverage plan using AI, ML. We've done it on limited designs, but some real projects as well. And we think we can effectively get a 10x improvement, which is game changing. Okay, so that's a big thing we found is just by using ChatGPT. We've got security issues, and we know there's potential security issues. So we only do it on some standardized interfaces, standardized designs, but we're seeing a speed up there. At the moment, we're on test bench generation and test generation. We're actually using it a little bit more on automation than necessarily AI. We have done some code generation, UVM code generation. So we've trained a bot to do UVM code generation, and we're seeing some good results. But I think there's already a lot of tools in the market, and there's a couple of talks this afternoon about just automation of UVM generation, and we'll see that this afternoon. So we think there's probably still a lot we can just do from automation rather than necessarily playing using AI in that. We've started to generate constraints using the LLM as well, and that seems to work well, because what we then we break it off the feature list effectively and put some constraint generation. And then for us, the simulation and the coverage closure is a much harder problem for us to solve. And we've been applying neural networks. This morning we gave the keynote at DVCon India, where we covered some of the ML techniques we've been using. So the TestSolve was given the keynote there. And we are seeing some reasonably good results. It's a much more difficult problem to solve, and it's much more. We can train this bot here can effectively take any spec, and you don't have to train it for a particular spec. We're finding with neural networks, you have to train it to the specific problem that they're trying to solve in terms of coverage closure. And there's a fair bit of research, still a lot of it in universities. A lot of it comes from EDA under the hood, and they're getting speed up. But we're actually trying to do some work into neural network. And debug as well. I think, as was mentioned, debug takes a lot of the time, a lot of the effort, and Cadence do have that solution now, which they acquired. I think they acquired the company 3 years ago, and we were working with that company for a while. Verifighter, a tool called Verifighter, and as you say, what it does is it learns from previous check-ins from the database, looks at what time it got checked in, how many owners for the file, actually looks at who did it as well, so I'm not sure if there's any privacy issues around that. But it's from all that information, it tries to predict where, and looks at the files in the simulation and tries to point you towards which lines of code to look at first and what the potential problem is. So that's from the challenge that's really hitting us all now. And I think, how do we use IML in our verification to try and make it more efficient and save on resources? This is the work we're doing. And I would say certainly LLM, we're seeing that as a game changer at the front end of the verification flow. Automation has been there a while. LLM is being used there. ML on coverage closure for us is still the tough one to crack. But we're working with various organizations and EDA companies and universities to try and fix that. So that brings me to an end. And I just want to make sure we're on time. So I will now pass over to Divyan, I saw earlier. That's brilliant, okay.
Yeah.
I didn't run away. I know I was looking for you somewhere. You're good. Okay. And you're PPT, aren't you? No, PDF.